Hey everyone, I hope you all are doing well in your academics and especially in IIT Madras BS Degree. Today we are going to do the graded assignment of Week 4 in Statistics-2. So, let us see the first question. The first question says that a petrol station receives supply of petrol once each the day. Daily petrol sale in thousands of liters are represented by the random variable x, which has the following probability density function, which is basically the fx of x is given as k times 1 minus x to the power 4 when x lies between 0 and 1. Else it is 0. What should be the minimum supply to the station in thousands of liters so that the probability of the petrol running out on any given day is only 1%? So, let us see how can we solve this. Here, x is a random variable which is basically the daily petrol sale in 1000 per liter. Let's first find the value of k. We know that the total PDF is always going to be equal to 1. So, let's integrate this PDF function from 0 to 1 with respect of dx and equate it to 1. After solving the integration by using substitution method, the value of k that we are going to get is k is equal to 5. If you guys feel any problem in solving this integration, then you can pause the video and see the calculation part also, or still if you don't figure out, then reach me out in the comment box. Coming back to the question, we get the value of k, which is basically 5. Now let us define S is equal to minimum supply of petrol. There is one point given in the question is that the probability of x greater than S is equal to 0.01. And here we need to find value of S. So, probability of x greater than S is equal to 0.01 can also be written as probability of x less than or equal to S is equal to 1 minus 0.01, which is 0.99. Now we get a CDF of S is equal to 0.99. Let us now find the equation of CDF. We know that the CDF is antiderivative of PDF, so it means that if we integrate the probability density function, then equation that we get is basically the CDF. The CDF that we are going to get is 1 minus 1 s to the power 5. So, earlier we get an equation of fx of x is equal to 0.99. Now it will be like 1 minus 1 s to the power 5 is equal to 0.99, which will be later look like 1 minus s whole to the power 5 is equal to 1 minus 0.99, which is basically 0.01. Hence, S is basically 1 minus 0.01 to the power 1 by 5. We know that 0.01 is basically 10 to the power minus 2. So, 0.01 to the power 1 by 5 is equal to 10 to the power minus 0.4, which is ultimately equal to 0.3981. So, value of S will be 1 minus 0.3981, which is 0.6019. So, the correct option for this question is going to be option C. Now let us see the question number 2. Let x be a continuous random variable with the cumulative distribution frequency given below. And we need to find what is the probability of x greater than 1 but less than 2. So we can write the probability of x greater than 1 but less than 2 as CDF at 2 minus CDF at 1. Let us first find the CDF at 2. Since we're taking x is equal to 2 here, so we will take the second component equation of CDF, or basically equation of CDF when it lies between 1 and 3. So, fx of 2 will be equal to 2 minus 1 whole to the power k by 8, which will be equal to 1 to the power k by 8. We know that 1 to the power any number is going to be 1 only. So, fx of 2 is basically 1 by 8. And similarly, if we find the fx of 1, then it will be going to be equal to 0. Hence, probability of x greater than 1 but less than 2 is equal to 1 by 8, which is basically 0.125. Let us now move to the next question. This question says that next 3 questions share a common data which is given below. This data is basically the CDF of a random variable x. Okay, so if look at the CDF, then we can see that there are jumps on each range value, which actually clears a point that it is going to be discrete random variable. We know that step function is used to represent the CDF of discrete random variable. So, if we create a step function for this given CDF, then this step function will be something look like this, where we can clearly see the jumps. Now in question number 3, we need to find the probability at x is equal to 0. We know that to find a probability of a particular value from the range of a discrete random variable using its step function, what we basically have to do is we have to find the difference of its jump or the length of its jump. So the probability of x is equal to 0 is basically going to be 1 by 3 minus 0, which is basically 1 by 3, which is 0.33. Hence the answer of question number 3 is 0.33. Similarly, if we look at the question number 4, which asks that the probability at x is equal to 1. So the probability at x is equal to 1 is basically going to be 1 by 2 minus 1 by 3, which is going to be 1 by 6. So the probability at x is equal to 1 is 0.17. Now if we look at the fifth question, which asks that the probability at x is equal to 2, then it is basically going to be 1 minus 0.5, which is going to be 0.5. Hence the probability at x is equal to 2 is going to be 0.5. It means that the answer of question number 5 is going to be 0.5. Let's now move to the question number 6. Question number 6 states that let x be a continuous random variable with a given PDF. Find the median of x. So, in this question we basically need to find for what value of x fx of x is going to be 0.5. First, let us find the unknown k in the given PDF using the fact that total or integral sum of PDF should be equal to 1. So, after integrating this PDF over the interval 0 to 1, the value of k which we get is 3. Now since we have a CDF with its value as 0.5, so we need to find the CDF by integrating the PDF. So the CDF that we get is x cube. Means that x cube is equal to 0.5. So the value of x that we will get is 0.7937. Hence, the median value of random variable x is 0.7937. Let us now see the question number 7. Question number 7 states that the lifespan of an electrical component that is used in a car has the following density function, which is given below. We need to find the probability that the electrical component lasts more than 200 hours. So, in this question basically we need to find the probability of x greater than 200, which is basically equal to 1 minus probability of x less than or equal to 200. Again, from the given PDF we need to find the CDF by using the integration method. So, the CDF that we are going to obtain after the integration is basically 1 minus e to the power minus x by 800. Now probability of x greater than 200 is equal to 1 minus e to the power minus x by 800, which will be equal to e to the power minus x by 800. So after putting x is equal to 200, then value that we will get is e to the power minus 0.25. So the probability that x is greater than 200 is e to the power minus 0.25. And let us now look at the question number 8. Question number 8 basically says that a meteorologist is studying rainfall patterns in a region. The CDF of the daily rainfall x in millimeters is modeled as fx of x is equal to 1 minus e to the power minus 0.5 into x. Okay. So this is basically the CDF of random variable x, that is the probability that on a randomly chosen day, the rainfall exceeds 10 millimeters. So this is a very easy question and I guess all of you might have solved this, but still let's see this. Here we basically need to find probability of x greater than 10, which is basically equal to 1 minus probability of x less than or equal to 10. Now we have the given CDF function, so we can easily calculate the probability of x less than or equal to 10. So, after solving the equations, the probability of x greater than 10 is equal to 0.0067. Let us now see the question number 9. The question number 9 states that the time delay d in a communication system is uniformly distributed over the range 5 to 15. And for efficient communication, this delay should not be more than 8 milliseconds. Determine the probability that the system operates efficiently for a single request. So the random variable d is basically the time delay in the communication. And d is uniformly distributed over the range 5 to 15. Here we need to find a probability of d less than 8, which is basically equal to probability of d greater than 5 but less than 8. One point to remember is, in uniform distribution, if we need to find the probability of x greater than a but less than b, then what we actually have to do is we have to divide the b minus a by the length of distribution, or basically means that the difference of upper range and lower range. So, the probability of D greater than 5 but less than 8 is equal to 8 minus 5 by 15 minus 10, which is basically equal to 3 by 10. So, the probability of D greater than 5 but less than 8 is 0.3. Now let us see the last question, which is the continuation of previous question, and here we need to find the probability of D less than 12 under the condition D is greater than 8. Probability of D less than 12 under the condition D is greater than 8 can be written as probability of D less than 12 but greater than 8 by probability of D greater than 8. So the probability of D greater than 8 but less than 12 is basically going to be equal as 12 minus 8 by 15 minus 10, which is basically equal to 4 by 10, which is basically 0.4. And in the previous question, we got the probability of D less than 8 as 0.3. So the probability of D greater than 8 is basically 1 minus 0.3, which is basically 0.7. Hence, the probability of D less than 12 under the condition D is greater than 8 is basically 0.4 by 0.7, which is equal to 0.57. Okay, so that is it for the graded assignment of Week 4 in Stats 2. If you have any doubt regarding any question, then drop it in comment box. Also, if you really learned something from my video and want me to continue, then please don't forget to like, share and subscribe. Guys, one thing observe is almost 80% of my viewer does not even subscribe me. Please don't do this. If you really learn from something, don't forget to appreciate. Also, you can join our Telegram community for further updates regarding our YouTube channel and BS degree also.